free-body diagram of the automobile which is being towed at constant velocity up the incline using the cable at C. And it's got a mass at G. The tires are free to roll. Okay, significance of each force. Yeah, you figure it out once you draw the free-body diagram. So, it says here, draw the free-body diagram of the automobile. So, if we got the car, I need to draw the outline of the car. So, outline of the car. Not good. I'm not drawing. It's not that good. But let us see if we've got a car here. I've got the outline of the car with the wheels, and it's got a mass M acting at G. So I've got the active force. I'm going for the active force. Okay, that's my active force, and I've got a pull force from the it's a cable. So cable connected here. So you know that the cable is always in pull. So that's another force I've got. So I've put all my active forces on it. Now I'm looking at the reactive force. Reactive force. Can I move the, if I want to move the it's an object. Yes, I can move. Okay. So it's where are the supports? Where is the support for the automobile? Can anyone tell me?
The wheel.
The wheel. So it's the contact with the ground. Okay. So there's a reactive force coming from the ground there. Is that clear?
Yes.
So that's it. So in simple word, this is your free body diagram. So I've got my active forces and I've got my two reactive force. Is that clear?
Yes, sir.
Let's look at another example. Says here, draw the free body diagram of the foot lever. Where the foot lever? This is your foot lever. This is the foot lever. So we won't have to draw the free body diagram of the foot lever. Okay, so free body diagram of foot lever. So in simple words, the ideal version is here. So I've got a force being applied. I'm looking at the active forces now. Okay, so I've got the force being applied here. That's the force being applied. I've got a link. So remember, it's a link. So the forces would be in this direction. I know that. So I'll have a force in this direction. I can have a force in this direction. It's up to you. But whatever you decide, stick to it. Do not change it later, because the answer will tell you if your assumption was right and wrong. That's by the sign. If the sign comes out negative, it's an indication that you assume the force in the wrong direction. And there's another active force by the spring that's here. Remember, I have to draw the free body diagram of this part. So I've got one active force, the other active force, the third active force, and any other active force? No. It is supported. So there's a support reaction. Support is pivoted. So at pivot, support reaction, I need to find the forces. Now it's a 2D. In 2D, a support has got how many degrees of freedom?
Sir, at max 3.
So 3.
3. Okay. So it's pivoted. So definitely it can rotate in this direction. So there's no reactive moment. But the pivot cannot move in this or this direction. So I will have two reactive force coming from the pivot. In simple words, your free body diagram looks like this. I've got my active force and I've got my two reactive forces. Once I draw the free body diagram, I do not look back to the diagram or the picture. I just focus on my free body diagram, and on that free body diagram, I apply my equation of equilibrium. Simple as that. So drawing the free body diagram is very important.
So the way we can have a different direction of forces at point B, can the direction of the forces?
Yes. You can.
So the direction of forces at AX and AY can be they can be of opposite direction as well also?
Yes, 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 yes. You can have your AY here, AX here. I can do that. But remember what I mean to say that wherever you put forces, some forces are obvious that you don't make a mistake. For example, this force, this F force is downward. It's obvious. Okay. And the force of a cable, you know that it's always in pole. So some forces are obvious. The rest of the force, you just put symbols and use your common sense. If you can get the direction sense out, then use a bit common sense. Otherwise, if I had my AY here, and I had my AX here, and I had my B force in the other direction, when I'm using the equation of equilibrium, my answer will tell me that if for this force, I would get an answer of minus 20 pounds, which tells me the direction of forces in the other direction. So don't worry about that. We will do exercise. We will do some examples where we apply equation of equilibrium, and then we get the answer. Okay. Now let's look at this example. I'm emphasizing more on free body diagram. That is very important in industry when you do analysis. Is the free body diagram where engineers get stuck. Once you draw a free body diagram, the rest is relatively very easy. So you draw a free body diagram of the crane boom. So that's basically this part. That's the part I have to draw the free body diagram of. Okay, so let's look at it. So I need to draw a boom for the crane. I want to now apply the active forces on it. The very first thing is to put active forces. So the active forces, I've got G that is acting downward. That's my G, that's the active force. The other active force is at B, because that's 112, sorry, the weight is 650 pounds. The other active force is at B here, which is 1250 pounds. Okay, now any other active force? No, there's no active force. Now this boom is being supported at A and B. So let me look at A first. That's my A point here. So A point is 2D, so support reactive has got 3 degrees of freedom. The boom can rotate at pivot A, yes it can, but the pivot A cannot move in XY direction. So I will have a reactive force at point B, AA. Now there's also a cable attached to point B. It's a cable, so I know the reactive force will be in this direction. So that's where you use your common sense. You cannot get the direction wrong for this one. So looking at my free body diagram, I've got my reactive forces and my active forces on it. So let's look at the free body diagram. That's your free body diagram, because on the free body diagram, remember, apart from the forces, you put all the dimensions, angles, everything needed for the calculation. Is that clear?